Alright, your Army Institute Professional Development Principles Internal Combustion Engine Subcourse 0 OD1619 Edition 8. Introduction. Military vehicles incorporate all forms of wheeled and tracked vehicles, including the full range of the body type of the commercial vehicles. These are also the body of the equipment that unique with military operations, include all the type of the trucks, tractors, personal carrier tanks, self-propelled guns, propelled, motorized, mechanical, special purpose equipment, trailers, vans, special purpose towed vehicles. Principal distinction between the vehicles of the commercial counterpart of the military vehicle that are specially designed with the military purpose. These include combat operation, transportation, cargo, personnel, equipment, towing with other vehicles, with equipment, other operation of both cross-country and over roads, and close combat, support combat vehicles, and troops. So vehicles are designed and constructed to endure rigid of a military environment and to continue operating at or above prescribed minimum performance level. They have the extent cross-country performance capabilities overall of the terrain where the tactical combat operations can be conducted. This includes snow, ice, rocky terrain, swamp, the desert stands. In order to negotiate water barrier, the minimum of the preparation of the sensitive equipment is either permanently waterproof. They're designed to function underwater. The majority of the vehicles described in the paragraphs above that have an internal combustion engine for the reason with the mechanical showroom with the principle of the operation for the engine. Its various components. Internal combustion engine is engine with the fuels that burn with the 4-stroke or 2-stroke cycle gasoline diesel engines are an example of the internal combustion engine because the combustion chamber is located with the engine and task of the internal combustion engine is referred to as a piston engine will be described. 2 piston engine characteristics of any engine operation general because of the most widely used with the piston engine with the 4-stroke cycle of the type of the will be used with the example of the paragraph as the base for the comparison of the task 2 of the operation. Piston engine can be best used to understood with the comparing the simple canyon with the view with the A with the figure 1 on the following page with the cannon barrel with the charge for the gunpowder and cannonball with the illustrated in view B. Figure 1, gunpowder is ignited. The gunpowder burns very rapidly. It burns with the rapid expansion with the result of the gap of rapid expansion cause tremendous increase of the pressure of the force of the cannonball from the barrel with the view of the air. The figure 2 on the following page, the cannonball has been replaced with the cylinder and combustion chamber. The cannonball has been replaced by a piston. Mixture of vaporized fuel air has been replaced by the gunpowder in view B. With the figure 2, the gasoline is ignited at the time the resulting force acts to push the piston downward. Alright, view A shows the barrel, the gunpowder, and the ball. View B shows the expansion. View A shows the fuel and air mixture with the combustion chamber, the piston, cylinder, and force downs. View B. Reciprocating motion with the rotary motion. The force of the piston act with the downward motion of the immediate valve with the turn of the wheels out of the vehicle. In order to use the straight line, reciprocating motion must be with the transfer and the rotary action motion. This is made possible through the use of the crankshaft. The crankshaft is connected with the driving wheel of the vehicle through the drivetrain. One end, on the other end of the shaft is the crank with the crank pin offset with the shaft center of the figure 3 on the following page. Shows the piston pin with the connection rod with the crank pin and the crank shaft. Illustrates how the piston and the crankshaft are connected with the rod crank pin with the figure 4 with the following page illustrating reciprocating motion of the piston constrained with the rotating of the motion of the crankshaft. The more detailed explanation parts for the perform the reciprocating rotating motion of the described in paragraph 3A of the page 15. 3. Intake of the exhaust of the engine. Stop the going with the operating with the fuel air mixture must be fed in the combustion chamber. The burning of the gases also must be exhausted. To accomplish this, there is a passage for the combustion chamber with the call for the intake port. A passage from the combustion chamber to the exhaust system called the exhaust port. A simplified arrangement is shown in figure 5 on page 6. By putting out opening for the combustion chamber, the problem will create with the force for the burning fuel with the air mixture will be lost for the exhaust and intake ports rather than use to push down the piston. To solve the problem, there must be something of the opening and closing the intake of the exhaust ports for the combustion chambers. To accomplish the valve is added to each of these ports. These valves are called intake and exhaust valves. A, B, and C and D show the rotation of the piston and then their strokes. Exhaust valve simplified arrangement shown in figure 6 for the following page. The intake of the exhaust valves are open with the closing time sequence with the valve train. With the valve train, we'll discuss in paragraph 2.5a on page 8 with the action with the cylinder when the piston is at the highest point. And the cylinder of the piston is called the top dead center. With the piston at the lowest point of the cylinder is in the position called the bottom dead center. As the piston moves the top dead center through the bottom dead center, the vice versa of the crankshaft rotates exactly 1/2 of the revolution is shown in figure 6 on the following page. This shows the exhaust port and the intake ports of the exhaust valves, the piston at top dead center and the piston at bottom dead center. Each time the piston moves with the top dead center with the bottom dead center with the vice versa. The complete for the movement coupled with the stroke with each piston is complete with the two-stroke with every fuel crankshaft revolution. The four definite phase for the operation engine goes through in one. A principal internal combustion engine, the OD161 lesson 1 task 1. Complete the operating and cycle for each of the one with the operating phase for the complete with the piston stroke because of each of the operations is also forward. Choose the stroke because of the four-stroke for the operation engine is referred to the four-stroke cylinder engine. The four-stroke air intake of the compression power with the exhaust because of the four-stroke is an operating one operating cycle that must be concluded that there are two complete crankshaft revolutions in each operation. Intake stroke figure 7 on page 9 with the intake stroke at the beginning of the top dead center with the move down with the intake with the valves open, the downward movement of the piston exhaust valve closed with the creative vacuum of the cylinder, the vacuum cover with the fuel air mixture with the drum with the intake port with the combustion chamber with the piston reach with the bottom dead center intake valve closed with the compression stroke begin with the piston with the bottom dead center with both the intake with the exhaust valve remain closed. As the piston moves with the top dead center with the amount of the space for the upper cylinder gets smaller, the fuel air mixture is compressed with the potential energy with the fuel is concentrated with the compression stroke end for the piston reach of the top dead center. Power stroke. As the piston reaches the top of the dead center, the end of the power stroke with the sparking nut plug ignites the compressed air with the fuel air mixture with the pushes. Because of the valves are closed, the force of the resulting explosion pushing the piston down with the given the powerful driven thrust into the crankshaft of the power stroke for the end of the as the piston reaches the bottom dead center with the exhaust stroke with the as the piston reaches the bottom dead center with the ending of the power stroke with the exhaust valve opens beginning the exhaust stroke with the piston moves upward toward the top dead center if the push of the burnout gas with the fuel of the air mixture out of the combustion chamber through the exhaust port as the piston reaches the top dead center, ending the exhaust of the stroke with the exhaust valve closes. As the exhaust valve closes, the intake valve opens to begin the intake stroke in the new cycle. Your valve train is important to operate the valve at the time sequence. Therefore, the engine is fitted with the valve of the train with the operator with the valve with the exhaust valve will open in the middle of the intake stroke with the piston would draw burnt gas into the combustion chamber with a fresh mixture of fuel and air. If the piston is continued with the power stroke, there was nothing would be nothing in the combustion chamber that would burn. And simplified valve of the train is illustrated in view A with the figure 8 on page 10 with the crankshaft that rotated with the crankshaft through the timing gears. The raised feet for the camshaft with the scallop with the globe, and as illustrated in view B with the figure 8 with the valve spring is designed to hold the valve closed. The cam lobe contact with the bottom of the lifter rotates with the camshaft as shown in figure C with the figure 8 with the cam lobe pushes up with the lift. It will then turn push of the valve open up against the pressure with the spring with the view D with the figure 8 with the cam lobe with the pass from the center with the lifter bottom of the rotates away from the lifter. The valve spring pulls the valve closed. The proper position of the cam lobes on the camshaft sequence can be established by the intake of the exhaust valve that's described in subparagraphs 2A, 4A, and 2A, 4D on page 7. How the intake valve of the exhaust valve must each on once every operating cycle explained with the subparagraph 2A, 4 with the crankshaft that must be two complete revolutions, complete one operating cycle. The U for the two factor for the camshaft speed with the be exactly one half of the speed of the camshaft that's accomplished for the time and gears are made, so that the crankshaft gear that only has exactly one half of the many of the teeth of the camshaft gear with the shown view A with the figure 9 on page 11. The timing marks indicate that you put the camshaft with the crankshaft in the proper position relatively to each other. Our figure A shows the intake stroke show with the intake valve with the intake port, and then B would be the compression stroke with the and then C would be your power stroke, and your exhaust port would be your exhaust valve and the exhaust port with the water compression and the exhaust also in the different shades. The exhaust valve, intake valve with the timing gears and the cam lobe and the valve tap it. Valve A, cam lobe, lifter, camshaft, valve, view C, valve seat, valve face, view C, and valve spring and valve view D. Alright, 6 engine accessory system fuel system for the fuel system supply for the engine with the properly proportioned fuel and air mixture for the regulated for the balance with the mixture supply for the engine control engine speed with the power output with the 10 principal internal combustion engine 081619 lesson 1 task 1 figure 9 timing gears and flywheel. The ignition system for the ignition system ignites with the fuel air mixture with the combustion chamber at the precise moment that needed to make the engine run. The cooling system remove the excess heat from the engine generated by the combustion. Indeed, the lubrication system and lubrication provides a constant supply of the oil to engage the lubricate and cool the moving parts. It shows view A shows the timing gear for the crankshaft gear move the 2 revolution. The camshaft gear moves 1 revolution. The crankshaft and the flywheel on the piston crankshaft on view B. Flywheel as in figure B, 9 view B with the discussed previously. Every 2 revolution the crankshaft makes the receive with 1 power stroke with left only one half of the 1 revolution. But the crankshaft that means but the engine must go with the 1 half and 1 half of the crankshaft revolution operating cycle. This would cover the engine to produce very erratic power output to solve the problem of flywheel's attitude at the end of the crankshaft and fly wheel, which is very heavy, that will absorb the violent thrust of the power stroke. The wit will be relieved the energy back into the crankshaft so that the engine will be run smoothly. Comparison of the engine type of the internal combustion engine versus the external combustion engine. The internal combustion engine, the U10 of the figure 10 of the UA, with the internal combustion engine is engine with the fuel burned within, and a fuel four-stroke cycle of the engine is internal combustion engine because the combustion chamber is located within the engine. Alright, combustion chamber A with the internal combustion engine. B, the external combustion engine, showed with the boiler, steam, water of the combustion chamber. Different matter, diesel, electric locomotive, steam locomotive, kind of, that's my best example. External combustion engine, figure 10 with the view B with the external combustion engine is an engine which is fueled by the burn outside of the engine. A steam of the engine, the perfect example, the fuel is burned by the outside water boiler, where the banks with the steam is pipeline to the engine makes it run. Four-stroke cycle versus the two-stroke cycle. The engine is described until now that it has been a four-stroke cycle engine. There is another form of the gasoline piston engine that requires no valve mechanism, which completes one operating cycle for every revolution of the crankshaft. It's called the two-stroke cycle engine illustrated. In Figure 11, instead of placing the intake and exhaust ports in the combustion chamber, they are placed in the cylinder wall. In this engine, the piston goes through the power stroke every time they move to the top dead center of the bottom dead center of the downstroke. This is also intake for the exhaust valve. As in the piston moves to the top dead center back to the top dead center, it's going through a compression stroke. This shows the piston intake and the exhaust ports, intake port, exhaust ports, and piston and crankshaft. Downward stroke. On Figure 12 with the VUA with the following page for the piston become power stroke with the top dead center, exploding fuel air mixture pushing piston downward in the first cover of the inlet port with the seal with the crankcase of the piston continues downward uncover the intake with the exhaust port with the pressure built up, and the crankcase force with the fuel and air with the mixture and so on through the intake port with the top of the piston in shape with the divert the mixture upward and away from the exhaust port. The mixture enters the cylinder, displacement is pushed with the burnt gas out through the exhaust port. Upward stroke with the Figure 12 with the view B with the as the piston moves upward, they cover the intake exhaust port with the seal of the upper cylinder with the stroke of the upward movement of the piston compressed with the fuel with the air mixture. At the same time, the upward movement of the piston creates the suction in the crankcase over the inlet port is uncovered with the mixture of the fuel air is drawn into the crankcase, and as the piston reaches the top dead center with the spark plug ignites the fuel air and mixture beginning with the downward powered stroke again. Exhaust is clear and the gas mixture is dotted. A shows the downward stroke of the piston intake of the exhaust port inlet port with also in the crankcase over the downward stroke. The upward stroke shows the move. Our fuel lubrication system for the fuel air mixture must first pass with the crankcase before it gets to the region with the combustion chamber for the reason the fuel air mixture must also provide the lubrication rotating reciprocating part accomplished by the mixing of the small percent of the oil with the fuel. The oil was mixed with the fuel air with the mixture with the engine with the crankcase and the vapor constantly coating the moving of the parts power output. This seems to be the two-stroke engine. Engine will put out twice as much power with the comparable than the four-stroke cycle with the engine because there are twice as many power strokes. However, there is not a case because of the force of the fuel and air mixture into the cylinder must be relied upon getting on the burnt gas within the cylinder with the last power stroke with some dilution of the mixture and then take the mixture with exhaust the gases reduce the potential power output. Also, the inlet exhaust ports open together with a certain amount of the fuel air mixture is left. This also must shorten the period in which the inlet port is open. The factors that reduce the amount of the power for each of the power stroke. Advantage is use the two-stroke cycle of the engine is used almost exclusively in very small equipment. It is lightweight and able to run at very high speeds to the absence of the mechanical valve train. Rotating and reciprocating parts of the piston. General figure for 13 with the piston with the part both the two and four-stroke for the engines receive the energy from the combustion transmitted to the within the crankshaft of the piston moves with a steady heavy stress on a severe temperature extremity of the following air mixture with the conditions that the piston must withstand the normal highway speeds. Shows the 480 to 500 degree top ring of the piston, 500, 800 to 700 degrees ring groove of the pin boss, and the 300 to 400 degree pin boss area of the skirt. As the piston moves with the top cylinder over the bottom of the vice versa, the accelerates to the top at the speed with approximately 50 miles per hour with 80 kilometers per hour. At the midpoint with the decelerates to stop again in approximately 80 times per second. The head of the piston is subject to the pressure excessive of 1,000 pounds per square inch, and this piston head subject to the temperature very well over 600 degrees Fahrenheit. Construction materials. When designing pistons, weight of the major for the consideration basic the tremendous inertial force created by a rapid change of the piston direction for the reach of the may be found with aluminum in the best material of the piston construction. It was very high strength of the weight with ratio in addition with being light when aluminum is an excellent conductor of the heat of the machine is easily. Piston also manufactured for the cast iron. The cast iron is an excellent material for the pistons and low speed engines. It is not suitable for the high speed because of the very high heavy material. The controlling expansion figure 14 on the following page Piston must have the built-in feature to help the control expansion. Without each feature, the piston would fit loosely with the cylinder with the cold with the bending with the seat cylinders as they warm up the problem. Aluminum becomes expanded so readily. The control expansion piston may be designed with the following features. A. The object with the ground of the piston will get hotter than the rest of the piston to prevent the expanding to the large side of the rest of the piston. The machine to do the diameter that is approximately 3/100 to 4/100 of an inch smaller than the skirt area. One A ways to control the expansion from the skirt area with this cut a slope out slot up in the side of the skirt with a split skirt. Piston warms up the split with will close up, and there will be keeping the skirt with expanding of the outward binding of the piston into the cylinder. Alright, the skirt is closing slot when expanding the slot in the skirt with the whole end of the slot prevents further splitting, and the retarder heat transferring from the head to the skirt, the T-slot within the skirt, and then you have the head is grooved in a 4/10 of an inch, 4/100 of an inch smaller than the skirt. The groove is cut in the position and retarder with the heat transfer from the head to the skirt. See a variation of the split skirt with the piston with the T-slot with the piston similar to the split skirt with the piston with addition with the horizontal slot with the retard, the heat transfer with the piston head of the piston skirt with the trim of the aluminum piston with the steel brake for the casting and then to control with expansion. Cam grinding with the figure 15 with the following beam making the piston head with the shape that will be able to fit the cylinder better than throughout with the operational temperature range of the piston with the configuration with the code a cam ground piston with the cam ground piston with the machine with the diameter smaller parallel to the piston pan axis with the perpendicular to it when the piston is cold. It will begin enough to cross the large diameter to prevent the crocking. As it warms up, it will expand across the smaller diameter, at which the higher rate than its larger diameter. This will tend to make the piston round at operating temperature. Virtually all pistons automotive applications are cam ground. A cold, B A warm from left to right. A is cold, A and B warm, and then hot. Partial skirt, slipper skirt with the piston, figure 16. The purpose of the piston skirt to keep the piston from rocking within the cylinder. Slipper skirt with the piston has the large portion of the skirt removed with the non-thrust area with the removal of the skirt. In these areas serves the following purpose to lighten the piston, which in turn increase the speed range of the engine. A, the full bar skirt is position, partial skirt is position. Reduce the contracting area with the cylinder wall with reduce the friction off ways position to be brought down with the cushion of the crankshaft without the interference with the counterweight strength. And the structure of the figure 17 of the following page of the design of the piston weight with the strength are critical factors to where the pistons are made with the strong and light air are as follows. The head piston pinhole with the skirt with the reinforced edge with the position piston pin with the pin boss with the reinforced bit ribs. The head of the piston made with the thin is practical to keep it strong with enough of the ribs to cap on the underside of the areas around the piston pin are reinforced with the areas of the pin boss with the coating of the aluminum piston usually treated on their outer surface of the engine, breaking the increase the hardness of the following area with the most common the process of the treatment of the aluminum piston. The piston's coated with the tin which will work on the cylinder walls if the engine is broken. The process result for the more perfect 19. Shorten with the break-in with the period with the increase overall engine with the longevity of the piston and anodized with the produce the harder outside surface of the anodized process for the producing coating on the surface of the electrodes for the precision process of the hardened surface of the piston that helps resist the picking up of the particle with making the embedded with the piston causing the cylinder walls to damage. B, the piston rings general the figure 18 with the piston rings serve with three important functions. Alright, the combustion gas is escaped into the crankcase. Oil from the crankshaft escape with the combustion chamber without the piston rings. The combustion gas is dot. The oil is full black. Alright, and with the piston ring, the piston rings keep the oil from entering the combustion chamber. The piston rings stop sludge. Alright, they provide a seal between the piston and cylinder wall to prevent the force of the exploding gap of the leak in the crankcase of the combustion chamber. But the leakage is referred to as blow-by. Blow-by is detrimental to the engine performance because of the force of the exploding gap of the merely bypass of the piston rather than push it down, and it also contaminates the lubricating oil of 20. The principal internal combustion engine OD 16-19-11 lesson 1 task 1 to prevent the lubricating oil from passing the piston for the getting it into the combustion chamber from the crankcase to provide a solid bridge to connect with the heating of the piston on the cylinder wall. About 1/3 of the heat absorbed by the piston passes the cylinder wall through the piston rings. Description of the piston rings are split with the allow the installation of the expansion, but they exert with the outward the expression for the cylinder wall with the install of the fit and the groove that are cut into the piston that are allowed to float freely in the groove of the properly formed piston ring with the working in the cylinder within the limits of roundness and size will exert the even pressure to maintain the solid contract within the cylinder wall around the entire circumference. Although the piston rings have been made with the many materials cast iron have been provided most satisfactory is within the same the good wearing surface that retains greater amount of the original elasticity after considerable use of the two basic classifications of compression ring, piston ring, with the compression ring seal with the force with the exploding mixture in the combustion chamber. This showed the cylinder bore outward pressure for all the directions of the ring and the ring gap, the compression ring, and the oil control rings. The oil control ring prevents the engine from lubricating oil getting into the combustion chamber. The configuration piston rings are arranged on the piston in the three basic configurations. They are three-ring piston for the figure 20 view with the two compression rings near the head, and followed by the one control ring, with oil control ring with the most common piston ring with the configuration. The three-ring with the two compression ring with the one oil control, the four-ring with the three compression rings with the one oil control, four-ring, two compression rings with the two oil control piston rings with the piston pin. The four-ring position has three compression rings near the head with the following one oil control ring. The figure of the commonly used the diesel engine because they are more prone to blow by due by much more higher pressure with the generator during the power stroke. With the four-ring piston ring have two compression rings near the head and then followed by the two oil control rings. The bottom of the oil control ring may be located above or below the piston pin, but it is not very common in the configuration of the current engine design. In addition to the configuration mentioned, there are some of the diesel engines that use the 5 or more piston rings to each of the piston to control the higher operating pressure. 4. Compression ring is stated in paragraph 3b2a on the page 21. The purpose of the compression ring is to maintain the gas type seal between the piston and cylinder. The top pressure with the power with the stroke for the combustion chamber is the mode differential cross-sectional shape of the piston rings available in figure 21. You have plain bevel edge, inner groove curve, inner groove square, outer groove square, scraper type, and plane. Additional tape steel rail for scraper effect. The various shape of the rings also serve to preload the ring with the lower edge with the pressure against the cylinder wall, as shown in figure 22 for the following page. For the serve of the following function of the pressure for the power stroke with the force of the upper edge of the ring and the contact with the cylinder wall, forming a good seal. B as the piston moves downward with the lower edge of the ring, scrape with any of the oil, the work past the oil control ring from the cylinder wall with on the compression from the exhaust stroke of the ring will glide over the oil, increasing the ring's life. This shows the cylinder wall with the piston with the intake stroke with the ring scrape the excess from the cylinder wall. The intake with the ridge ring rides on the filing with the oil with the prolonged the ring life of the piston with the cylinder wall compression exhaust stroke. The power stroke show the firing and the push of the ring downward until the entire ring of the face engages the cylinder wall head and the fired fuel, max fuel, and air mixture dotted, and the piston. This shows a 90-degree angle on the separation between the rings. Second compression shrink with the primary with the second compression ring. The whole back and blow by with the may occur at the top of the ring with a significant amount of the total blow by at the top of the ring will be from the ring gap for the reason from the top of the second of the compression ring is assembled on a piston gap with the offset with 60 degrees. The oil control ring of the figure 24 following the page. Oil control ring serve the control lubricating of the cylinder. They do this by scraping the excess oil with the cylinder wall with the downstroke of the oil with the engine force through the slide of the piston ring and then the piston ring groove with the draining back into the crankcase. The rings are made in many different configurations. One piece for the unit with the multiple piece assembly. Regardless of the configuration, all oil control rings work basically in the same way. Your operation for the this is the piston downstroke with the cylinder wall clear with scraping the edge being scraped, oil being scraped, the oil ring of the oil falling into the crankcase, the ring slot, and then the piston oil ring of the groove at the bottom of the section of the piston oil collecting with the oil ring scraping action. Variations: slotted beveled edge, the rain slot, the slotted square edge with the steel slide rails, steel slide rail at the top and the bottom, steel rails with a slot expander, and the slot expander as a ring. For the conclusion, describe the operation of both the two-stroke with the four-stroke engine with the gas engine for the next half of the operational information for the diesel engine will be discussed. Lesson 1, internal combustion engine is task 2. Describe the principal components of the operation for both the two-stroke with the four-stroke diesel. Introduction, task 1 with the general gas piston engine with the discussion task with the operation four-stroke gas engine with the four with the stroke of the diesel engine will be carried in addition with the information will be provided in the two-stroke diesel engine for the combustion chambers. 2. Gasoline engine versus the diesel engine in general. The very many respect with the four-stroke cycle. Gasoline engine with the four-stroke cycle. The diesel engine are very similar, but they both follow the operating cycle with the existing intake of the power compression power stroke and exhaust stroke. They share the same system in the intake of the exhaust valve. The components of the diesel engine are shown in figure 25. With the main difference between the gasoline engine and the diesel engine as follows: the diesel engine fuel air mixture with the heat generated with the compression stroke versus the use of the spark ignition and the gasoline with the diesel engine. Therefore, needs no ignition system for the reason of the gasoline engine engine is referred to as a spark ignition engine, with a diesel engine is referred to as compression ignition engine. With the diesel engine, with the fuel air mixture with the compressed is about 1/20th of the original volume. Contrast the fuel and the air mixture with the gas engine is compressed to about 1/8 of the original volume. But the diesel engine must compress with the mixture with the tightly to generate enough to heat to ignite the fuel and air mixture. The contrast between the two engines is shown in Figure 26 on the following page. All right, this shows the exhaust of the injector intake port with the exhaust valve, the intake valve with the piston connection around with the crankshaft. The gasoline engine mixture with the fuel air before the reach of the combustion chamber. The diesel engine takes out only air from the intake port with the fuel is put in the combustion chamber directly through the injection system. There in the fuel, then mixture in the combustion chamber. This is illustrated in Figure 27 on the following page. The engine speed with the power output of the diesel engine are controlled with the quantity of the fuel emitted with the combustion chamber. Show the gasoline compression ratio of the 1 through 9, bottom dead center over the top dead center of the gasoline engine with the compression ratio 1/20, 1/15, 20, bottom dead center, top dead center, compression, and stroke. The amount of air in the constant with the contrast with the gas engine with the wear speed with the air power output is regulated, limiting the air intended engine with the compression illustrated in Figure 28 of the following page. The air intake with the fuel air mixture with the air. The fuel air mixture enters the gasoline engine. The fuel air is injected by the fuel air and injection combustion chamber of the diesel engine. Gasoline and diesel engine. Okay. All right, operation intake Figure 29 with the UA with the page 32 with the piston, top dead center at the beginning with the intake stroke with the edge of the piston, move it downward, the intake valve with the open for the downward movement of the piston, drails the air into the cylinder, as the piston reaches the bottom center of the intake valve with the close for the ending, the intake of the stroke with the compression Figure 29 with UB with the piston with the top of the bottom dead center at the beginning with the compression stroke, piston upward. All right, this shows the air, the throttle valve, the gasoline, the engine, the accelerator, the motion of the regulates the fuel delivery with the diesel engine with the fuel injector. Okay. Compression air stroke with the piston reaches the top dead center with the compression stroke with the 3, the power stroke, power with the Figure 29 view with the long page with the piston begin with the power stroke with the top dead center. This time the air with the compression from the upper of the cylinder is about 500 psi. Tremendously the pressure over the upper cylinder bring with the temperature of the compressed air to approximately 1,000 degree Fahrenheit. The power stroke will then begin with the injection of fuel charge into the engine. Heat compression ignites the fuel as it is injected. The expanding force of the burn gas with the push of the piston to with providing the power of the crankshaft with the power generator. And the diesel engine is continuous throughout the power stroke with the contrast with the gasoline engine with its power stroke with rapid combustion with the beginning with little or no combustion at the end. The exhaust of the Figure 29 view D of the piston reaches the bottom dead center with the power stroke ending with the exhaust stroke with the beginning of the exhaust valve opening. The piston pushes the burnt gas out through the exhaust port. After the piston reaches the top dead center, the exhaust valve closed with the intake valve with the open. The engine is then ready to be another operating cycle. A is the intake position, B is the compression stroke, the 3 C is the power stroke, and D is the exhaust stroke. Advantage: the diesel engine is more efficient with the gasoline engine due to the much tighter compression with the fuel air with the mixture. The diesel engine produces a tremendous low speed with the power to get the greater fuel mileage than gasoline counterpart. This makes the engine very suitable for the large truck. The diesel engine requires no ignition tune-up because there is no ignition system. Because the diesel engine is often oil consistency and less volatile, the gasoline is not likely to explode in a collision. Disadvantage: the diesel engine must be made very heavy to have enough strength to withstand the tighter temperature with the fuel air mixture with the diesel engine. Very noisy. The diesel fuel creates a large amount of fumes because the diesel fuel is not very volatile. Cold weather starting with the difficulty. The diesel engine operates well only with the low speed with the range with the relationship with the gasoline engine. The creates problem with the use of the passenger car with the wide speed range. The use of the diesel engine are widely used in all the type of the heavy truck for the trains and boats. In the recent years, more attention has been focused on using diesel in passenger cars. Multi-fuel engine with the Figure 30 with the following page with multiple fuel engine, basically 4-stroke cycle diesel engine with the capability of operating with a wide variety of fuel oils without adjustment and modification. The fuel injection system is equipped with a device called the fuel density capacitator with the job to vary with the amount of fuel, keeping the power of the output with a constant regardless of the fuel being used. Multiple fuel engine used with the cylindrical combustion chamber to be added to aid throughout the mixture with the complete combustion of the minimized NOx. There's a picture of the engine. Two-stroke cycle diesel. Generally, two-stroke cycle diesel shown in Figure 31 found with the base hybrid engine sharing with the operating with the physical with both two-stroke cycle engine. Gasoline engine, 4-stroke cycle diesel engine with a major feature for the engine or as valve. The complete for the operating cycle every 2 piston stroke for every crankshaft with the revolution listed for the two-stroke cycle engine with the provide with the power stroke for every time with the piston move down with the compression ignition engine to make it the true diesel engine. Also exhaust valve on the top of the combustion chamber that is 4-stroke cycle diesel engine intake of the ports are cut in the cylinder wall as in 2-stroke cycle engine gasoline engines. This shows the injector superstarter piston with the connection route, the crankshaft with the inlet port, with the exhaust valve port, with the exhaust port and injector. Diesel engine air entered through the intake with the port with the fuel injected into the combustion chamber about the fuel injection. Sufficient air supplied with the engine constant while the speed of the power output of the engine is regulated with controlling the quantity of the fuel injected in the combustion chamber. Unlike any other engine of the type of the two-stroke diesel engine must have the supercharger to force the air into the upper cylinder of the muscular common type U of the Rudies. Operation figure 32 with the following page for the scavenging. The scavenging begins with the piston at the bottom of the dead center with the intake ports for the uncovered, but the cylinder wall of the exhaust valve opens. Air is forced in the upper cylinder by the supercharger as the air is forced and the burnt gas of the previous operating cycle are forced out. So the scavenging, compression, and the three in the power and exhaust. Airflow, mixture, and exhaust. Compression is the piston moves down to the top dead center with the cover of the intake board with the exhaust valve closed to the point and seemingly the upper cylinder of the piston continues upward in the air of the cylinder. Slightly compressed as the four-stroke cycle diesel with the tremendous amount of the heat is then generated by the compression of the principle of the internal combustion engine at less than 1 task 2. Power of the piston reaches the top dead center with the compression stroke with the engine with the fuel injected at this point with the intense heat with the compression caused with the fuel to ignite with the burning fuel push the piston downward, give it the power to the crankshaft. Power stroke aimed for the piston gets down to the point where the intake ports for the uncovered at the point where the exhaust valve opens and scavenge begins up again. Advantage of the two-stroke cycle diesel the engine has all advantage of the four-stroke cycle the engine has over the gasoline engine plus the valve. Because of the two-stroke cycle engine runs smoother than its four-stroke cycle counterpart because of the power stroke generated at every crankshaft revolution. The two-stroke cycle has the less complicated valve train because it does not use the intake valves. Disadvantage of the two-stroke cycle engine must be with the supercharger to force the intake of the air with the push out with the burnt gas exhaust gap. The pickup of the movement of the piston is not such that it will accomplish naturally. The supercharger usually engine power to the operating two-stroke cycle diesel with either two or four-stroke exhaust valve. The cylinder will complicate with the valves mechanism. With the two-stroke cycle, the gasoline engine with the diesel counterpart will not produce twice as much power as the four-stroke cycle engine, even though it produces twice as many power strokes with the body setting. With the figure 33 of the following page, the you can see the power stroke occupies only the portion for the downstroke of the piston. Two-stroke cycle diesel and four-stroke cycle diesel with the power of the stroke lasts for the top dead center to the bottom dead center. Uses of the two-stroke cycle diesel engine used the most from the sample application of the four-stroke cycle diesel. All right, you have the two-stroke cycle diesel with a power stroke and your four-stroke cycle diesel engine with a power stroke. Okay, the combustion chamber is designed with the fuel injected with the combustion chamber that must be mixed with thoroughly compressed air with the body distributed evenly as possible throughout the chamber. If the engine functions with the maximal drivability, well-designed diesel engine use the combustion chamber that is designed for the engine's intended use. The injector use of the engine should be complement the combustion chamber. The combustion chamber described in the following some paragraphs are most common in the cover. Virtually all of the design use the current automotive applications. Open chamber figure 34 with the following page for the open chamber. The simplest chamber, the form of the chamber, the suitable for the slow speed with the four-stroke cycle engine with the usually wide and the two-stroke cycle engine with the use. And the opening of the chamber, the fuel is injected directly into the space at the top of the cylinder. The combustion chamber space for the form with the top of the piston with the cylinder head is usually space to provide with the swirling action of the air. The piston comes up on the compression stroke. There are no special pockets itself. The passage to add the mixing of the fuel with the air with the type of the chamber required for the higher injection pressure for the greater the degree of the fuel atomization that is required by the other combustion chamber to obtain an acceptable level of fuel mixing with this chamber. The design very susceptible to the ignition lag. Then that's the picture. Pre-combustion chamber, the figure 35 of the following page. Pre-combustion chamber, the auxiliary chamber at the top of the cylinder, that connect with the main combustion chamber by restricted the throat and path of the pre-combustion chamber, the condition of the fuel and the final of the combustion of the cylinder, the hollowed out the portion of the piston top comes cause the turbulence of the main combustion chamber of the fuel engine for the pre-combustion chamber of the day, the mixing with the air, the following step of the curve during the combustion process. 1. During the compression stroke of the engine, air is forced for the pre-compression chamber, then because of the air with the compression is at the beginning with the injection of the pre-combustion chamber that contains the definite volume of the air. This shows the pre-combustion chamber and the injection and the power stroke. As the injection begins with the combustion begins with the pre-combustion chamber, the burning of the fuel combined with the restriction path of the main combustion chamber that creates the tremendous amount of the pressure in the chamber. The pressure in the initial combustion because of superheated fuel charge and to enter the main combustion chamber with a tremendous velocity. The entering of the mixture hits with the followed out with this on top of the creating of the turbulence with the chamber to ensure complete mixing with the fuel charge of the air. The mixing with the ensure the even the complete combustion with the chamber design will provide the satisfactory performance with low fuel injection pressure for the course. spray patterns because of the large amount of the vaporization take place with the combustion chamber. The chamber does also not vary with the susceptible to ignition lag, making it more susceptible to high-speed applications. The turbulence chamber, figure 36 of the following chamber. The turbulence chamber is similar appearance for the pre-combustion chamber, but its function is different. Very little clearance at the top of the piston, but the heat of the and the head is a high percentage of the air between the piston and the cylinder head is forced into. Turbulence chamber, during the occurrence of a compression stroke of the chamber, the jubilee cylindrical opening of which whether the air must pass becomes the smaller as the piston reaches the top of the stroke of the air by increasing the velocity with the air speed of the chamber. The turbulence speed with approximately 60 times crankshaft speed with the fuel injection the time of the curve, and when the turbulence in the chamber the greater the ensure of the through the mixing with the fuel and air, it will result with a greater part of the combustion take place with the turbulence chamber itself, with the pressure created with the expansion of the burning gas within its force of the drive of the piston downward on the power stroke. This shows the turbulence chamber, the injection begins and the power stroke. Cylindrical combustion chamber. This figure 37 on the following page. Cylindrical combustion chamber that is principally designed for the use of the multiple fuel engine, with the chamber that consists of the basic open top of the chamber, the cylindrical space for the relief of the piston, and have the chamber that works with the conjunction with the strategically positioned injector with the intake port that they produce the swirling effect of the intake air with the engine of the chamber, and the operation of the chamber is as follows. Alright, the air intake with the passage of the shape of the produced and air swirl in the cylinder during the intake stroke with the piston, the intake stroke in the air swirl continue throughout the compression stroke. The air swirl continues during the fuel injections of the injected fuel mixed directly within the air molecules and the tight of the cylindrical combustion channels. That's in the fuel injection. Air swirl continues to move only with the upper surface of the reported fuel onto the piston with the cylindrical combustion to change throughout the power stroke with the piston, maintain even combustion. That was the power stroke. The exhaust stroke is burned with the gases, then exhausted the exhaust port of the stroke on the piston to complete the cycle. As air into the combustion chamber with the swirl effect introduced by the shape of the intake of the figure 37 of the UA with the principle of the internal combustion to OD 1619 less than 1. Task 2, during the compression stroke with the swirling motion of the air, continue with the air temperature with the chamber to increase the figure 37 of the U on the previous page. The fuel is injected approximately 9% of the deposit for the head of the system, remainder mixture of the air in the cylindrical combustion chamber to figure 37 of the UC. If the combustion begins with the portion of the fuel is swept off the piston with the head with the high velocity which was created with the intake of the compression, the stroke with the fuel is swept off the head with the burn through the power stroke with mainly even with the combustion eliminating detonation of figure 37 of U, D, and E. 6th, conclusion. This concludes the explanation of the gasoline and diesel engine internal combustion engine. For the next lesson, operational information subsystem of the internal combustion engine will be discussed. Lesson 2.